Hello Data Pros, welcome back to another exciting video in our DBT series. In our previous video, we learned about DBT doc and doc block features. Today, we'll shift our focus to Jinja, a highly valuable feature within DBT. In fact, we've already started using Jinja in our code. The popular ref function that we've been using is one of the Jinja constructs. DBT developers mainly use three languages: SQL for creating models and tests, YAML for configurations, and Jinja for making the SQL and YAML code dynamic and reusable. Jinja is a powerful templating language. While in the DBT it's predominantly used to generate dynamic SQL code, here is an example that showcases how Jinja can be used to generate a dynamic HTML code. Before I discuss a DBT Jinja real-world project use case, let me familiarize you with the building blocks of Jinja with a simple example. Anything that starts and ends with curly braces and percentage is called a control statement. Examples of control statements include variable declarations, if conditions, and for loops. It's important to note that the contents of control statements are not printed in the final generated code. Anything that starts and ends with double curly braces is called an expression. The contents of expressions are evaluated, and the resulting values are printed in the final generated code. Anything you write without any curly braces is called text. Texts are not evaluated, they are simply printed as is in the final generated code. Lastly, anything that starts and ends with curly braces and hash are comments. Comments are neither printed nor processed, they are just for our understanding. Here is a simple Jinja code that uses all the Jinja building blocks that we have just discussed. The first line is a comment. All these are control statements that basically control the program flow, but are not rendered in the generated code. All these are texts, at runtime they will be rendered as is in the generated code. Lastly, this is an expression, at runtime this will be evaluated, and the resulting value is rendered in the generated code. Let's try to compile the code and see what the output is. This is awesome, isn't it? Having gained familiarity with Jinja and its ability to generate dynamic code, let's now delve into real-world project use cases. In one of our projects, we successfully passed all our DBT tests in lower environments. However, when we moved to production, we encountered several issues. Upon investigation, we discovered that the tests in lower environments were run with insufficient test data. Consequently, our business expressed the need to incorporate this check as the initial test in our future testing cycles. To address this requirement, we defined the bare minimum number of rows for each table that would be considered adequate for thorough testing. We then developed this Jinja test SQL that can be used to generate dynamic test code for multiple tables. Let's put this code in a .sql file in the test folder. At the beginning, the code defines a dictionary called expected counts. This dictionary contains the expected number of records for each table. It's worth mentioning that the Jinja allows us to leverage various Python data types. For this case, we've used a dictionary data type. Next, we have a for loop that iterates through each item in the expected counts dictionary. Let's assume the first loop starts with the customers table. Inside the loop, we extract the table name and expected count from the current iteration. We also get the actual record count from the data warehouse. If the actual record count is less than the expected count, the code generates a record. As learned in our DBT testing video, it's crucial to note that if the test SQL generates a record, it will result in a test failure. If you need further clarification, please feel free to refer to the video link in description. The loop continues for the next table in the dictionary until all tables have been processed. Without Jinja, we might need to create separate test files for each table, which would result in more than 40 lines of code. However, by employing Jinja, we can consolidate the tests into a single code block, spanning just 20 lines. We shall now proceed with executing this test. Upon completion, we find that the test has passed, confirming that we have sufficient test data in each individual table. To further evaluate the effectiveness of the test, let's attempt to delete some rows from our customer table. Returning to DBT, we shall rerun the same test. This time, the test has failed. This outcome confirms that one or more tables do not possess enough test data. We could now execute this test as the first step in our testing cycle, so that future test cycles will pass only if each table has enough test data. Jinja has versatile uses beyond testing. For instance, here's an example that demonstrates how Jinja can generate a dynamic SQL for a DBT model. Additionally, here's another example illustrating how Jinja can generate dynamic YAML configurations. Overall, Jinja offers numerous advantages that enhance code reusability, reduce the overall lines of code needed, and significantly improve readability and maintainability of your code. That's all I've for today. Please stay tuned for our next video, where we'll deep dive into DBT macros and packages. Please do like the video and subscribe to our channel. If you've any questions or thoughts, please feel free to leave them in the comments section below. Thanks for watching.